Alright, so we'll be learning something new this time around, and then we are starting from our knowledge on numbers. Is that okay? Who can remember the first time they had a contact with numbers? It looks virtually impossible, but can anybody remember the first time you heard 1, 2, 3, 4, 5, 6? What was that? When you're in crèche. Who else? Crèche. Okay. All right. So what then are numbers? What are numbers? You from where? Class 4. Okay, probably she means something else. But what are numbers? So we've all met numbers before. What are numbers? Yeah?
Numbers are
Counting something. Nah.
numbers are used to represent objects.
So numbers are symbols. So these numbers are symbols used to represent objects. So for example, I have markers here. So I can use a number to represent. So this is 2, right? So we can simply write numbers are symbols used to represent things around us. Okay, we will look at various types of numbers. I think over the time we've even spoken about other types of numbers already. That we've all come in contact with numbers before when we were learning fractions. Types of numbers. Who can remember any 2 types there? Huh? Whole numbers, composites, and all that. Okay, however, we want to look at 2 types of numbers whose knowledge will help us understand today's lessons. We start from natural numbers. So what are natural numbers? Anyway, what are natural numbers? Kelvin?
Natural numbers are numbers that start with 1.
Yes, numbers that start with 1. Okay, what's any other definition? Or what's another name for natural numbers? Yeah. Who can? It starts with a C. Yeah, counting numbers. So natural numbers are also called. So natural numbers or counting numbers. They start with 1, right? So 1, 2, 3, 4, 5. You can't count anybody from 0. Do you count and start saying 0, 1? How would this guy feel if you count him as 0? So we don't count from 0. So counting numbers start from 1. Then the second one is whole numbers. What are whole numbers? That will be what?
Whole numbers are numbers that start with 0.
0. So the difference between natural numbers and whole numbers will be 0, right? So can I therefore say that all natural numbers are whole numbers?
Yes.
Some people said no.
Yes.
Because from 1 to this place will be natural, right?
Yes.
So natural plus 0 will give you whole numbers. So simple, is that right? Okay, we'll look at the third one, which is our main lesson for today. It's called integers. But before we talk about integers, take note of this. The first 3 words, this INTE here. Who knows any word with this with INTE? INT, an English word. Yeah, international. Okay. What other word? Yes. Integrate. Yeah, but where do you usually find that word? Integrated science. Yeah. So that word integrated would help us to explain what integers are. So take note of the word integrated. Yeah, I know you've seen that in your book before, but you see, when I was younger, we used to learn. Now you see the junior high schools learn integrated science, When I was younger, we would learn general science, which is biology about plants and animals, then physics about machines and all that, about forces, and then there is chemistry in that. That's general science. Then we also learned agricultural science. So we had general science. So we have a general science teacher, watch here, and then we also had an agricultural science teacher. Then after some time, the government decided, okay, let's put the agricultural science and then the general science together and call it integrated science. So that means that the whole agricultural science and general science have become one whole, one complete thing. Do you understand? So whenever we say integrated, we mean that it is whole, it is complete, or it is united. Are you following? So integrated means what? It is what? It is united, it is combined, it is complete. The science is now complete. There's no more agri science somewhere. There's no more general science. We have brought all of them together and made it one whole thing. So that's what we call integrated. Now, so it is from where? So integrate and integers. So integrate the same root word. They have the same basic word. So if integrates means to have a whole, what do you think integers or integer numbers will be? And now, so integers are whole numbers. Do you understand? Integers are just whole numbers. But you'll be like, I said, but we already spoke about whole numbers. So how different are integers? Does anyone have a question like that in his mind? Yes. The slight difference is that for whole numbers, we are just looking at numbers from 0 till. But for integers, we bring another new element. We bring another new element which we call negative numbers. Do you understand? Why negative numbers? You know that? Who has ever seen a negative number somewhere before? Where? When you're on a calculator and you dial numbers. Okay, so calculator. What else? Marilyn? When someone borrows credit, you realize that you see, usually when you have credit, you see, let's say, 50 something Ghana cedis or 5 cedis credits worth credit on your airtime on your phone. And when you don't have credit, you realize that you have 0.00. When you are below 0, that means what? You have borrowed. You would have what? Negative something. Negative 5. That means you borrowed 5 cedis. You are owing. Who is an example of negative numbers? You've met negative somewhere. Yala? The weather. You see that on a thermometer. You realize that the temperature has gone below something, negative something. Do you understand? So negative numbers are all around us. So the reason we need a system where we would have to account for. So whole numbers are the ideal. Now we need a system where we would have to account for things that happen below 0. Are you following that? All right, we'd have to account for things that happen below 0. So let's say, for example, when I'm in a car, you see. Okay, let me give a good drawing here. This is the sea, right? Yeah. And then we have some mountains here. Okay, let's say a water body or sea, whatever. And then we have, what things will be up? Clouds. Birds, clouds. We can also have birds.
The sun.
Yeah, and we have planes. So let's say some planes are all around here.
The sun.
How do you draw a plane? Oh. Yeah. This plane, the sun. Yeah, all those things. What things will be below the sea? Submarine. That's was it what? Back by here. No, that will be where? On top of the, so a dark, right?
Yeah.
Okay, so what things will be below the sea, below the surface of the fishes? Below where? So fishes. How do we call those people that dive in the water? How do we call them? Hey, Mami Ata. Yeah, they have some name. Yeah? Is it? Scuba. Is it scuba or Cuba? Scuba divers. So they look, how can I draw them? I pray I don't end up drawing a mermaid. But they look something like this. Let's try and represent them. So scuba divers. This is not deep enough. Let me color code this. Fishes. And all these things. So these guys are below. So if the surface of the water is going to be 0, we have to use a system to represent things happening below. Do you get that? So that's how we represent these guys with negative numbers. And then these things happening here are going to be positive. Is that okay? All right. So this is the reason why we would have to learn about integers. So whenever and temperature, so, you said weather, right? So temperature too, when the temperature is, let's say this is a thermometer. And the temperature is, let's even assume we have 0. 0 degrees is the freezing point of ice, right? The point at which water becomes ice is 0 degrees. So watch here. So it means that when you go 5 degrees, it's going to be a little hotter than ice, right? I go 10, I go 15, I go 25, and I go 30, right? Right? Now, what if I want the thing to be very cold? Where do I go, up or down? Down. So I go negative. It's negative 5, negative 10, negative 15, negative 25, negative 30. Is that okay? So the more down I go, the colder it becomes. Now let me tell you a story. See why it's important you learn maths. So you know the air condition. When you on it, and let's say it's around, what's the usual temperature it has? 16, right? But you see, when you get used to the fan usually, when you want to go to when you want the room to, or you want to regulate the fan to be more comfortable, you move from 5 to 4 so that the temperature goes down, right? Yes. Oh, yeah, so that things become okay for you. But the AC does not work like that. So there was this lady, he doesn't know how integers work. So he took the AC, she was feeling very cold. So she wanted to regulate the AC. So the AC was around 16. So, let me reduce it small. Guess what she did? She took it down to 15. So it's getting colder. What's happening here? She reduced it down again. Think that, let me reduce the AC small. It's too much. Let me reduce it. By the time she brought it to 5, so she's actually shivering over there. So that same thing, for when you go down, you are getting what? Colder. So when you want to reduce the AC to be warmer, you rather go up. Is that okay? So it's so important we learn about integers. Okay. From what I just described, learn this works. You see what I just drew over here? We'll need it very much for a lot of things we'll be learning in maths. From Joe, are you there? We'll need it so much for a lot of things we'll be learning in maths. We need it for how to plot graphs. Have you ever seen your seniors do that before? A certain graph where somebody will put a plus here, then they'll put minus here. Have you seen that before? Yes. Then they'll put another minus here. Yes. Then they'll put some plus here. Then they'll put a y here. Yes. Then they'll put another y here. Then they'll put an x here. Then they'll put another x. Who said what? Please, it's still x. So this thing, what I just drew here, pay attention. is what we call the Cartesian plane. Say Cartesian plane. Cartesian plane. Yeah, plane. Plane, not like plane like a surface. Plane like a plane, like a place. Plane, not plane like the one that flies. All right. So the Cartesian plane. What here? It's just simple. You know what I said that when you are going down, what are you going? Are you not negative?
Yes.
So down is what?
Negative.
Down is what?
Negative.
Down is negative. Now, when you are making a forward, when you are advancing, okay, when you are going up, that will be what?
Positive.
Up will be positive. So I'm going up, making a positive word. Now, what if I'm going forward? I'm marching forward. So forward will also be what? So positive. What if I am going backwards?
Negative.
Backwards?
Negative.
Okay. Negative. So this is why we put a negative. This is why we put a negative here. Put a negative here. Put a positive here. And then put a positive here as well. So upwards is what?
Positive.
Upwards is what?
Positive.
This place. Because you are walking, you are moving backwards. When we are writing, we even write like this. If you are writing, I say, hey, this guy, what's wrong with him? We write like this. So positive, negative. Is that okay? Is that okay? So let's try. Everybody watch here. So I'm moving up is what?
Positive.
I'm moving down.
Negative.
I'm moving forward.
Positive.
I'm moving backwards.
Negative.
I'm moving forward.
Positive.
I'm moving backwards.
Negative.
I'm moving forward.
Positive.
Forward.
Positive.
Forward. Backwards.
Negative.
Downwards.
Negative.
Clap for yourselves. Okay. All right. So we are. Where's Lele? I brought my friend. So we have Lele in class today. Clap for Lele. Our new friend Lele. Shout out to Lele. Lele is going to help us in our lesson today. Lele.